everyone, so here are your 0.2 notes. This section is going to look at types of numbers, and it's also going to look at rounding. So the first thing that you want to be able to do is identify types of real numbers, and also you want to be able to round whole numbers. Just for the sake of simplicity, sometimes I will have us skip a few parts of the notes and things like that. So I'm actually going to have us start with just skipping this explore problem and also not worrying about the discover problem. So as you work through this section, I want you guys to keep the following questions in mind. Can you list different types of numbers and when they might be used? And also, do you know how to round a number in different ways? Okay, so we're going to begin with real numbers and their definitions. So the set of real numbers includes numbers that can be represented on a number line. So if we can put it on a number line, then it's considered a real number. For example, 3, 0, 1/2, -5.7, pi, all of these are real numbers. So just as a side note, the only not real numbers that we're going to be dealing with, or that you would really encounter, we won't really be dealing with them in this class, are what we consider imaginary numbers. And you guys may have seen those with, they usually use the letter I with those. And they usually write it a little bit curly like that. Or imaginary numbers are also when we have a square root with a negative on the inside. And if you were to ever type that in your calculator, you would see that if you take the square root of a negative number, it would show as undefined or math error. Okay, getting into our types of real numbers, because all of the numbers that we're going to be looking at are real numbers. We have our counting numbers or natural numbers. So they can be called counting or natural numbers. We usually will call them counting numbers. And I like to think of these as how you teach a little kid to count. So when you teach a child to count, you don't start at 0, you start at 1, and then you continue from there. 1, 2, 3, 4, 5, all the way forever. So the other one that we just have as an extension is whole numbers. So the only difference between whole numbers and counting numbers is the number that they start with. Whole numbers include 0, whereas counting numbers do not. Integers then expand into all of the numbers that are both negative and positive versions of our whole numbers. So it's our whole numbers and their opposites. So we also go in the negative direction, -1, -2, -3, all the way to like -1,000,000 and so on. Rational numbers are numbers that can be written as a quotient. A quotient is just a fancy word for a fraction. And with those, they can either be decimals that terminate or repeat. They would be considered rational numbers. So with these ones are nice and clean, whereas these ones are not as clean. So these ones have no pattern to them as well. So if you were to take the square root of 5 and put it in your calculator, you would see that it's a pattern that doesn't really make a lot of sense. Just like with this one, we don't have a very clear pattern with this, so this would be irrational. And with pi, it's actually irrational because it goes on forever and it doesn't have a clear pattern. So all of these are considered real numbers. And one thing to also consider is all real numbers are going to be either that or that. They're either going to be rational or irrational. So they'll always fit into one of those two categories. Now, they might also be these other ones, but all real numbers will definitely always be at least rational or irrational. Okay, for example 2, we're going to be looking at filling in the boxes and just kind of giving us a visual for our different categories of real numbers. So I told you guys that real numbers can either be rational numbers or irrational numbers. So that's how they're first going to be broken down into either rational numbers or irrational numbers. Now, we can also break down rational numbers into more specific types. If they're either the whole number or their opposites, then they are considered integers. The more specific, so as we work from the top down, we get more specific. So the more specific ones would be our whole numbers, and then our most specific are going to be our counting numbers, because counting numbers don't include 0. Another way that you can think of this is with kind of a circle chart. We've got our real numbers in our overall circle chart. They can either be irrational or they can be rational. Within rational, some can be integers, some can be whole, and then within that, some can be counting. This is similar to if I created a chart that showed the overall US, and we've got the Midwest, and then we've got Illinois, and then we have, say, Peoria. So one thing that you want to kind of have as an idea is Peoria will automatically always also be in Illinois and in the Midwest and in the US. But not every place in the US is going to be in the Midwest or Illinois or Peoria. So we can say that counting numbers are always going to be whole, integers, and real numbers, or sorry, rational numbers as well. But we can't say that every rational number is going to be a whole number or a counting number. We can't go the other way. So we can take our most specific and say that it's the other ones, but we can't go the other direction. So for example 3, we want to use that same idea that we were talking about with how we think of naming these. So it says to state an integer that is not a whole number. So in order to be an integer, it just has to be one of the whole numbers or its opposite. So if it's not a whole number, something like -5 or -3,000. If we have a negative number, it's automatically going to be an integer, but it's not going to be a whole number like that. A rational number that is not an integer. So a rational number can be written as a quotient, which means a fraction, but we don't want it to be an integer. So like we wouldn't want 4/2 because that could also be written as 2. So that wouldn't help us. But if we did something like 2/3 or -1/2, those would work. For part C, it says list all of the integers between -10 and -5 inclusively. So that's including those endpoints that they gave us, or those boundaries. So we would have -10, -9, -8, -7, -6, -5. But if we have it exclusively, we don't want to include those endpoints. So we're going to have -9, -8, -7, -6. For E, it says state an integer that is also a counting number. So if we have an integer that's also a counting number, we want it to be just a positive one that's 1 or more. So we could use 1, or we could even go like much bigger and we could say 4,892. Either of those would work, and a lot of others. The last one says to write a decimal that is irrational other than the examples previously provided. So we just want to write a decimal that if it's irrational, it doesn't have a nice pattern to it. So like 0.3297124, and just have it keep going on forever. Another example would be negative 10.73965. Just have it keep going on forever. Okay, that covers what we are learning about classifying numbers. The next part that we are going to be looking at is with place value. So for rounding, the real number system is positional, and digits have different values depending on where they are placed in the numeral. Place values differ by powers of 10, with each place value getting 10 times larger as we move to the left in the numeral and 10 times smaller as we move to the right. Place values are named starting on the left in groups of 3 separated by commas. So you can see that we have groups of 3s separating our commas, and we have ones, tens, hundreds, and it shows up as 1, 10, hundreds in our thousands places, in our millions, ones, tens, hundreds, millions, and billions and trillions, and so on. If we look at numbers as being also the relationship that they are to smaller ones, we can think of 1 million the same as 10 hundred thousands, or 100 10,000s, or 1,000 sets of 1,000. So it's a way for us to even think of it in the context of where we're looking at the decimal, or not the decimal, but the actual place value. Okay, so for this one, I'm going to have us actually read the rules down below just to help us out first. So the rules that you'll see in the following how it works are based on the visual idea developed here. We are going to round numbers by reporting them to the closest appropriate multiple. If a number is exactly halfway between two such multiples, so like if we have a 5 as a deal breaker, we will usually just round it to the higher one, or we will always round it to the higher one. So the first step to round whole numbers is to identify the target digit in the requested place value. And I usually will underline this number. Then we're going to look at one digit position to the right. And what I will do with this is circle it. I will circle the number to the right because that tells me if I'm going to round it up or not. We will replace all the digits to the right of the target number with zeros. So if this target digit is that we circle is 0, 1, 2, 3, or 4, then the underlined one is going to stay the same. If it's 5, 6, 7, 8, or 9, the target digit, the one that's underlined, will increase by 1. So for this one, it says to round to the nearest tens place. So I'm going to underline the tens place. So I'm going to underline the tens place, and I'm going to circle the digit to the right. This digit is a 6, so that means that I'm going to round the underlined one up by 1. So it's going to be a 1, and then everything that follows will be a 0. There's only one digit to replace with a 0 for this. So rounded to the nearest 10, we get 910. Okay, this one says to round to the nearest 100. So in the hundreds place, I have this 9. I'm going to circle the digit to the right. It is a 9, so that means I'm going to round this up. Now, you might be thinking, how do I round up a 9? Well, what I do is I think of this as just a group together. This number is 19, and now I'm going to round that up. So if I round up 19, that's 20, and then these numbers get replaced with zeros. So my answer is 2,000. For part C, if we round this to the nearest 1,000, my number that I'm going to underline is the 6, and I'm going to circle the 5. The 5 tells me I'm going to round up. So the 6 will become a 7. And the rest following will become zeros. For example 5 on the next page, it says to round the number to the place value indicated. So we're using the same number for each of these problems below. So for this one, 67,259, rounded to the nearest 10,000s, we would be rounding to the 6. So the 7 is the number that I'm going to circle. It's a 7, so that means it's going to be rounded up. So that will become 6, 1 up will be 7, and then the rest will be replaced with zeros. So I get 70,000. To round to the thousands place, the number in this one that I'm going to underline is the 7. The number that gets circled is a 2. This one, we aren't going to round up because it is just a 2, so it's just going to stay the same. So we get 67, it stays the same, and then the rest get filled with zeros. If we were to round it to the nearest hundreds, I'm going to underline the 2. The 5 will tell me if I round it up or not. 5 or more, I'm going to round it up. So I get 67, and that 2 will become a 3, and then everything that follows will be a 0. So 67,300. And the last one, I'm going to round to the nearest tens. So I'm going to underline the 5. The 9 will tell me if I round up or not. I will. So that will become a 6. The 5 will become a 6, and anything that follows will just be a 0. So I get 67,260. Something to keep in mind, not all numbers are included in the real number system discussed in this section. Square roots of negative numbers are not real numbers, but are instead a set called imaginary numbers. Imaginary numbers are expressed in this special format. We won't really be dealing with these, so it's not anything that you have to worry about. For example 6, it says to use your calculator to find the values of the following square roots. State the results shown on your calculator. So when you use your calculator, you should find a button that has the square root button. If you're not sure how to actually locate it on your calculator, that is something to Google. I would Google the name of your calculator. So type in the name of the calculator, and then also add in square root button. So just type in the name of your calculator and the square root button, and then you should be able to Google some directions on how to actually find how to do that on your calculator. So for the square root of 9, if we type that in our calculator and press enter, we get a 3. And if we look at that, we also want to say if it's rational, irrational, or imaginary. The 3 can be written as a fraction. It's a nice clean number. It doesn't keep going on forever, so this would be rational. Okay, if we type in the square root of 10 into our calculator, it will give us the decimal 3.162278, and you'll see that it keeps going. There's no clear pattern to this. This one doesn't make any clear sense. So with this, it would be irrational. For this one, if we type in a fraction into our square root, we end up with 1/3 or 0.3 repeating. It can be written as a decimal with a nice clean pattern. It's just 3 repeating. and it's written as a fraction. So either way here, we have a rational number. This one is an example of a negative inside a square root, so this one would be imaginary. It also would show up as a math error when we put it in our calculator. Okay, this should help you with all of the things that you'll need to complete the 0.2 homework on my math lab.